Hello developers, let's start developing. I am Vekoslav and today we're taking on the 16th day of Advent of Code 2023. So as the story goes, the image starts looking kinda okay. So we're at the lava island, seems that we will go back to the gear island for the next one. And we're in a cave. Great. And we have a flat two-dimensional square grid containing empty space, mirrors, and splitters. Yay, a matrix. So we're gonna have a matrix and we have a beam of light that heads in going that way. So goes from this line to this line. And we have some rules. If the beam continues empty space, it continues in the same direction. If the beam encounters a mirror, it's reflected. So if it goes that way, it's reflected. And it counters that kind of mirror, it's reflected in that direction. We will need to do some ugly code to actually manage that. So it changes the direction of the beam. If the beam encounters the pointy end of a splitter, these two are splitters, it just moves through it. And the fun thing, if the beam encounters the flat side of a splitter, it's actually split into two beams, which means that we have multiple beams going through the grid, through the matrix. So in this case, we have this thing gets actually split. And from what is basically seen, that when it gets to the side, it gets absorbed. Mm, it gets absorbed. I will need to find where that is, but that's what it is. So beams are only shown on empty tiles. If a beam passes through any of the tiles in any of the ways, including the mirrors and the splitters, then that tile is energized, otherwise it's not. If it's energized, it's a hash. If it's not, it's a dot. And we need to count out how many tiles get energized. So we need to do, this is a kind of naturally recursive task. So we're gonna use recursion, and we don't want to miss the last dot. So that will be our input, and our actual input will be basically a cell. Change this with a cell array because it's going to be a matrix of cells, and we will define what a cell is. So a cell is either a dot or that kind of mirror or the other kind of mirror or a splitter or that kind of splitter. No, it's pipe, and this is supposed to be a pipe as well. I have no idea. Yeah, this needs to be escaped. So basically a cell is one of these. Of course, we're gonna read all the input lines and lines.map, line.split, a cell. Those are our cells, return the cells. And once more, we're gonna use print matrix to make sure that our input is correct. If everything runs smoothly, we should get this. Hopefully we don't have too many recursive paths and too many ways to mess this up. I think that most of the beams will either cycle or get absorbed or something like that. We'll see. Anyway, we're getting this thing. Our transformation is okay. So whatever we put in, we are able to transform it into this, and then we're able to get it out. So that's good. And now we can say, let's create a beam. It's something that has an X and a Y. Oh, and this says, yeah, I will use this, the dx and the dy, but not just yet. It will have a direction going that way, right? Which means that we also need a type for the direction. Up, down, left, right, and we're gonna need an interface for the beam. Let's have a point. That usually gets handy, and then we can have a beam that, we're not gonna do that, we're gonna reuse it. So this is a directed point, so to say. So our beam will be a beam. And I have an idea how to avoid recursion. I'm gonna have a queue of beams. So this is our initial beam. And while we don't have a, you know what? Since we're gonna be splitting our beams, what we're gonna thinking of is some weird scenario. Because if we see here, we do have this thing that enters the splitter on the right. Because let's see what happens. Initially we get here. This gets split up. The top beam goes nowhere, the bottom beam goes here. It gets split up, this goes nowhere, this goes here, goes through that, gets bounced here, that gets bounced here, gets bounced here, it goes down, it gets split up, it gets split up again, that gets absorbed, this gets here, it gets bounced, it goes up, it gets split up, one part of it goes here, and gets split up again, and runs the cycle again. So we have a cycle. So if we just wait for all of the beams to get absorbed, some of them will never get absorbed. But on the other hand, if we have two beams that is coming from here and that is coming from here, and this is we already have a beam over here that goes down, we can count that as the same beam. So we might need some more data to see, because if we have another beam that goes in that direction, that's a different beam. It might end up in a different place. But if we already have a beam going down, that's okay. So we might want to make our cells something like that. So this will be, no. we want this to stay a matrix. So we're gonna map each row into a row once more, but a row of something else. Cell and X into an object with these values. That has an X. Yeah, the X and the Y we don't need because we already have that. So we're gonna have the cell, which is the value, and then we're gonna have left, which is false, right, which is false, up, which is false, and down, which is false. So this means, do we have a beam that goes through here in that direction? And I think we need yet another bit. So our data cells are basically a matrix of these values. So initially everything is false. Actually, it's not. We have one beam at the top that goes in that direction. So now we will have a queue, and while we have things in the queue, yeah, this will work. We move along. Oh, and we will have, yeah, whether a cell is activated or not is basically, if any of these are true, that cell is activated, which means we have a beam that goes through it running in some direction. Okay. So we can calculate it after the fact. We don't need to calculate it immediately or now. Yeah, we could, but we'll see. I don't think that we will have performance issues, at least with part 1. I have no idea what part 2 is, and I hope it's not too hard, because usually for starting with problem 16, 17, we have the weird problems that are really hard to do. And so, while we have something in our queue, I will do beam is u.shift. This is a bad name because we're gonna actually rename this start beam. That's the start beam. Once we put it into the queue, we don't really care. So I'm gonna do a weird thing. We're gonna take a beam, move it one uh, position away, and then leave it. So that is the cell. What is the next cell? So we are already on a cell. We don't care what the current cell is. We have the direction. So we want next cell. Actually, that will return a point, which we can destructure in this, which says next cell, get next cell, using for that beam and that data cells. Let's call this next point. Anyway. And now we need to implement this one, and this will be where we're gonna start our ugly code. We can use some magic like and say that this is a data cell matrix. We needed to do something else here, but this will work. So we need to see what the no, this won't use the ugly code. We will have another method where we have the really ugly code. This will be a relatively straightforward. Huh? Yeah, this makes some guess that is totally wrong because we're gonna need some much simpler code. We will just say if beam dot direction is up, we're gonna return a new point where x is beam dot x and y is beam dot y minus 1. And remember, we are using the weird positioning where y is the first coordinate, y is the row coordinate, x is the second one. So to go up, y goes up minus 1. So y grows in this direction, not in this direction. So if we're going up, y gets decreased. Yeah, just that. So we can just say now, if we're going down, increase y. If we're going left, increase that. If we're going there, we increase that. So we're getting just an x and a y. No way to do this smaller. It's ugly and straightforward code. And we can actually deconstruct it. Since this returns, it cannot return anything else. But it might be correct here because I will just put in some code that checks if beam direction is, because right now this should be actually this. So that's what I'm saying that it should know, but just for any case, we're gonna throw an error that says unknown direction, beam direction. This should never happen, but better safe than sorry. In any way, right now this knows that we have an X and a Y, and I will add some more ugly code that I want to hide. So if beam dot y actually is 0, that means we're out of bounds, return null. If we're going down, if we are at the end, return null. If beam is x, x is 0, return null. And if we are at the end of the column, at the end of the row, return null once more, because we're trying to go right and we don't know how where. So now this method actually returns either a point or a null. So we cannot destructure. So it's not get next cell, gets next location. And we can say if we didn't return a point, that means this beam got absorbed. This beam got nowhere. It ran straight into a wall. Otherwise, and now we have the next location. So now we have, it doesn't matter which direction we're going, we know what is the next one. But we need to get the next cell. It's this thing. And now we know that we have good values, otherwise we would have continued on. But note that this will be decreased because we took that beam out of the queue and now we're processing the next one. So we have our next cell, which is a data cell. And we need to see what the next direction will be. So if we have a dot, what happens now? We're not going to continue. If it's a dot, we need to just pass through it. We don't change the thing, so we will set that beam X is point of X, beam Y is point of Y. We don't change the direction. We will push the beam to the Q because it's continuing. But we will also need to mark next cell in the direction of the beam as true. That means that cell has a beam in that direction. And actually, has a beam. What does the next cell beam direction means? Does it mean that that cell has a beam that comes in from that direction or leaves in that direction? I will choose this to mean that it has a beam that comes from that direction. So we can say if the next cell of beam direction, if it already had a beam that came from that same direction, we can continue. The more proper way would be to actually do the opposite, because right now, if we have a splitter, just like this one, when we have this thing coming up from the right, actually from the left going right, we will set left to true. We will actually set right to true, but who cares? It's symmetrical. And if we have a beam coming up this way, we will set right. We will set right to true here. We will set left to true here, and we will treat those two as kind of different beams. But they will get absorbed once they get to this point. But we won't stop them on this thing. We will stop them on this field. But this makes the code easier. So our code is a tiny bit less performant, but it is a lot clearer. This means that a beam going in that direction entered our cell. So if we have that the cell dot left is true, that means a cell got a beam that entered from its right side going left. So with this simple line of code, we are making sure that we break all the cycles. A cycle just cannot happen. Otherwise, we need to do this. So if the next cell is a dot, we do that. No, this is going to be much more complicated. If the next cell is a dash, let's start with that. because these are kind of simple. Yeah, we kind of needed that. We're gonna move on to that point and turn it. But if it's going up, it should be going right. If it's going down, it should be going left. If it's going left, it should be going down. If it's going right, it should be going up. Okay, thank you, Copilot. This is correct. And we set that thing, we set that thing. No, we're not supposed to set that thing here. We're gonna set this here because we will get into a problem when we get to the splitters. And now we have this, and this needs to be just the other way around. Up is left, down is right, left is up, right is down. Everything else is the same. So handled dots, handled mirrors, we now need to handle the splitters. So if this cell is a pipe and we're going up, or you can see that this actually generated kind of stupid code because the code is exactly the same. And I wanted to say that it doesn't matter for this if we're going up or we're going down. We're going on the straight edge, on the pointy end of a splitter. So that means we're just going through the splitter. And this is not going to be end. It says if it's going up, then it's not going down. This is an impossible condition. Typewise. So we will have this and we will remove this. And I will, for good measure, add a continue here. And I think that we're missing a lot of continues because we don't want to actually run all the checks if we already know that the cell is a dot. So whatever you do, it's continue on. So if we're going up or down, we just treat it as empty space with the exact same logic. X is X, Y is Y. We're pushing the beam and we're continuing. Thank you and see you. Otherwise, that means we're pushing on the flat side of the splitter. So now we need to throw away this beam and generate two different beams. So we're gonna have an up beam and a down beam. And yeah, we will need to push that on the queue. And notice that we're not pushing our original beam. We're treating our original beam as if it got absorbed. So the upper beam, no, we already have the next point. So this will be a simple thing. And its direction is up. And its direction is down. And we need to push them and we're done for that thing. And now we need to hope that Copilot got what I'm doing. So if we're going left and right, basically ignore it and continue. Otherwise, make a left beam and make a right beam on the same position and push it to the cube. And just I will add a continue here because that is the other option, and I think we covered all the options. So if we get here, it means that we messed something up. As I said, this is the ugly code. Let's see right now. So after this is done, we have our next cells marked, so to say. And so we should data cell. We should, yeah, I'm gonna use a for each. No, I don't want to do that. Oh, I will use a print matrix. Cool, but I'm gonna use data cells. And I will add a processor. A processor is basically a function that I define that depends on the value of the data cell, will print out something. So I will say if cell dot up or cell dot down or cell dot left, then we're returning an X, else return a dot. That was how it was done? No. If it's energized, of course it's a hash. Otherwise, it's a dot. So we're gonna print it that way and see. So, well, first of all, I'm quite anxious to see if this ever terminates, because using self-modifying queues, the queues that are modifying within the loop seems odd. So it's quite easy to get code that never terminates, but we did mess somewhere up because it says that a dash is an unknown cell. I know what a dash is. Let's go into this 100 line monstrosity. We have a continue. Ah, we don't have a continue here. Yeah, so I'm continuing each time when I'm done with something, even when it doesn't really make sense. Oh, not only did it finished relatively fast. And it actually gave us a result. Let's see if we did manage to result, and now we just need to count the energized tile. That will be this same code, only we're gonna need to say count and const energized are data cells, and we're gonna need to sum over each row, where for each row we do, yeah, that is correct, but it's very, very ugly. I'm gonna add make it into a filter that says not and, but or. Give me that cell if one of these values is true. And then map them. Oh, no, not map them, get the length. So we are just counting for each row, get only the energized cells, and then set the length. I really hate this, so I'm gonna do something else. That's not very efficient, but I'm gonna say a data cell also has an energized That's Boolean. Now it will say, oh, I don't have energized here. Yeah, you do. It's false. And when we're setting the direction, we will always set it to energized. Because once we have a beam that goes through that, it's energized. It doesn't matter in which direction it's going. So if we have 20 beams going in different directions through that cell, we're going to set over and over again to true. But true is true. It's not going to change. Okay. Hide this away. We don't want to see it. Because right now our filter is much better looking for its cell. Give me cell energized. This is better, and also we can have if cell dot energized, then return a hash or a dot. Looks much better. Yeah. At the cost of very little memory. It says result part 1 is 45 because I got over eager. The first cell is energized. We don't really need the print matrix. Yeah, we know what we're gonna get, but I want to see it. I don't really trust any kind of code that should work. 46, correct. We also don't need the first print matrix. And now we can go and get our input. Oh, we might have a bug. And I think we do. The issue is that we are on this thing going left, so our next thing is gonna be this one. I don't like it, but I'm gonna push it. We didn't save. Seven, 4, 3, 4. Oh, this is hard. I don't want to put it in because I know it's gonna say it's the wrong answer. No, it's the right answer. Okay. Oh, I guess it doesn't really make sense because that is a bug, and I'm quite sure that the guys that are designed the input designed it this way intentionally. So you get the correct. Yeah, I might sound a bit paranoid, but to be honest, I feel kind of vindicated by some facts that the inputs are always kind of set up in a way that you might get the correct answer with the wrong algorithm, at least for part one. Because right now we should get deflected immediately down, but I guess there's a scenario that has a beam that comes through this way, so it actually all the same points are energized. Because not that it doesn't really matter how the things got energized. It only matters that they got energized. And let's see. Leads you to a nearby connection buttons. Lets you align the contraption so that from enters from any edge tile and heading away from that edge. Okay, so it says we don't have to push in from the 0, 0 going that position. We can push in basically from each of the edges. Any tile in the top row, any tile in the bottom row, any tile in the leftmost, any tile in the rightmost. Produce lava. You need to find the configuration that energizes as many tiles as possible. This should be straightforward. But I do have a feeling that it's gonna come in, that our bug is gonna come in here. What is the issue? We have our first beam. We can need to treat the first beam as if it appeared from outside. So this code is kind of wrong. We might need to do a loop and a half or invert and move around some code. I will try to rework part 1. Actually, let's see what happens. As it is, we should get here and then move on to here. So on that cell, we should energize that cell and that energize that cell and that energize that cell and that energize that cell and then energize that cell. But I think that what we're doing here is we're energizing that cell, energizing that cell, energizing that cell, and then that cell, and so on and so forth. Let's debug this. Other than that, once we fix this, and once we get a correct answer in either case, it will be relatively trivial. We just need to extract all of these things with the queue into a method, which I'm definitely up for. So we have our first beam that says I'm on the X and Y and I'm going right. Our next location is on the first row, second tank. And our next cell is a dot. And if we were working correctly, our next cell should have been a pipe. So yes, we do have that bug. That is confirmed. We don't need to debug anything. We know that this is a bug and we got lucky by having the correct answer. So we need to do it we need to take a step back. Ah, I have an idea which just might work. If we say that X is, if we're going right, our next direction, we're going right, our next direction will be X plus 1 beam Y. So we're just gonna say we're starting from here. Since we don't use these for anything before we get that, then we just don't even need these lines. And the start beam is starting from outside, just outside our matrix. And we actually use that beam for its direction. We're only setting. We're never using beam.x. The only place where we are using beam.x is over here. And here we want to use it to get that the next point will be 0, 0. And the next point will behave in the correct way. Let's see if this makes sense. So we have the beam, the queue is empty, and the next location is 0, 0. We entered into that, it exists. So the 0, 0 cell is a that character, it's a mirror. We entered from the right, it is energized. Is it a dot? It's not. Is it a hash? If it's up, we're gonna go down. Yep. And the next beam is going down from 0, 0. And the next location is 0, 1. Our next cell is the pipe. Let's just let this continue to run. And we actually got the exact same answer, but now without the bug. Ooh, this is tricky because we would have gotten something a little bit off. And the only clue we have is this. Because everybody would have started from inside the matrix. But now we will start from outside the matrix. On the other hand, I hate matrices very much, but I love saying matrix. Oh, that should be a function and will get energized count. So we're gonna need the input and we're gonna need the start beam. And I know that we are remapping the input, so this is a non-destructive on the input. We will get our answer from the data cells arrays, which is actually a copy of the input. So we are modifying the data cells array, but the next time when we call this, it will just be different, because we will be calling this quite a lot. And let's have it as a function. I will just put it way up before part 1 so that we can actually use it. And we can do that and never take a look at it again. Let's see if this thing works after our refactoring. Refactoring shouldn't change any behavior of the code when looked from outside, but let's check. This works. So what do we want to do now? First of all, we want to go back to the small input. And you can see we have a few cases, only a few cases, when we have elements on the zero. So now, instead of having a start beam for part 2, I will just copy it over. Let's remove that. We're gonna need to have a for loop. Yep, something like this. Only instead of having this here, we will need to have something like this. No, 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 no. We will need to have two for loops, one looping through the x's and one looping through the y's. because this will give us a Y for each row. And for each row, we have a left beam and a right beam that we can try. That's a beam that starts from -1 Y going right. And we're gonna have a right beam. Yeah, of course. And we're gonna have a right beam that, if we have 8 elements, starts at index 8, which is invalid. Moving left. We're gonna have right energized, and we're gonna have our maximum value, which is number dot negative infinity. So this is literally, we're saying this is totally off. So whatever number we get, it's gonna get bigger. And now we're gonna say max is, actually I will do this because I want to see how it moves. Of course, it's not gonna be a constant. So we do that. For the x and the y's, come on, guess correctly. Yes, we're gonna have an up beam that starts at -1 going down, and we're gonna have a down beam that starts at y going up. And then we just return the maximum. So once we did all the magics with the Q and whatnot, basically the second part has was mostly typed by Copilot. So we start at left beam as 0 has 46, so the left beam of 0 will always get mentioned because that's the first we run. But then we have the left beam at 2, which has actually 49. And the up beam at 3 is better because it has 51. Let's see what this thing says. Starting the beam in the fourth time from the left on the top row. So starting it from here. And the down beam on that. Okay. Oh, that's the up beam, I think. The up beam is going down. Yeah, and that's the up beam on 3. And we're fine with that. 51 tiles are energized. I'm gonna assume that's the same, but why not? Let's check. Oh, we don't have the matrix, otherwise we would have to do a lot of prints and whatnot. Let's not do that, because I am quite confident that this, it kind of looks okay. It has the correct fill, and let's see what happens with the big input. If we saved, yeah, we did. So we have the left beam at 0, the left beam at 5, the right beam at 5, the right beam at 10 has 81, 83. We waited a bit because we have to go through all of them. And to be honest, I don't think that we can actually optimize this because we just have no idea. So we will just have to let it run. And let's see if this is actually correct, 81, 83. Yes, it is. It had a feel of being okay. And we can actually see from here that we finished the lava island, because right now lava is going back to the gear island. But I'm quite sure that there will be something messed up on the gear island next, so we will need to fix that as well. And On a other note, I always love the ending animations for Advent of Code. This one was something about the wormhole. I think this one was a fun one. Yeah, we're basically traveling through the solar system, visiting all the planets and doing things with them, and the the sun is a star as well. So we have solved that. Let's go back to the current event. We have 32 stars. And we have some more stars that we will be able to get tomorrow. Until tomorrow, don't forget to click on the good buttons, not on the bad button. Don't click on the bad button. And we will see each other tomorrow when we're gonna take on task 17. Until then, keep developing.